Welcome, everyone. My name is Charles Henderson, and I'm your MC this evening. I have been a professor for nearly 35 years in the Department of Geology, then the Department of Geology and Geophysics, then the Department of Geoscience, and most recently in the Department of Earth, Energy, and Environment. Each name change reflecting the broadening of our discipline, proving that some change is good. It is wonderful to have so many people join us in person and online for our inaugural EARTHx series talk featuring our own Dr. Rachel Lauer. This year's EARTHx series has been generously supported by the Gallagher family, and you will hear more about them from our dean. We've organized tonight's event as a hybrid presentation so that we can continue to engage with the attendees from around the world and also to welcome audience members to our campus. Whether you are here in person or joining us online, we're glad you have decided to spend some of your evening with us. I'd like to mention that tonight's Q&A session after Rachel's talk will include questions from our live stream and in-person audience members. And the live stream audience members can text their questions to our team at 403-708-5749. I think that number will be on the screen at a later time. Many of us are fortunate to call this beautiful and peaceful region our home. This evening, I would like to take a moment to acknowledge that we also live, work, and learn on the traditional territories of the people of Treaty 7 region. They include the Blackfoot Confederacy, composed of the Siksika, Piikani, and Kainai First Nations, as well as the Tsuut'ina First Nation and the Stoney Nakoda, including the Chiniki, Bearpaw, and Goodstoney First Nations. The city of Calgary is also home to the Métis Nation of Alberta, Districts 5 and 6. We also acknowledge we are standing on land that is situated immediately adjacent to the Bow River, a river that has shaped this land and its people since the end of the last ice age. The traditional Blackfoot name of this place is Mohkinstsis, which we now call the city of Calgary. Since 2015, our department has had the privilege of organizing the Gallagher Colloquium Lecture Series, now known as EARTHx. These presentations have allowed our department and the Faculty of Science to welcome and host world-class researchers who all share a passion for science, scientific research, and exploration. I'd like to take a moment and recognize the Gallagher family for making this series possible through their generosity and vision for deep connections between the university and the community. We are grateful to be able to host this important lecture series. The Gallagher family support allows us to promote and build public awareness for science and scientific research and helps people understand why science is fundamental and important not only to our own lives, but also to the future of the world we all share, that is planet Earth. I'd like to welcome Dr. Kristen Bates, the Dean of the Faculty of Science, on stage to say a few words about this department and science's role in our community. Kristen.
Thank you. All right, thank you, Charles. I am Kristen Bates. I'm the Dean of Science, and I'm super excited to be here with you tonight. I'm seeing people here from not just the geoscience department, but from faculty all across the university. I am seeing alumni, future scientists, and also lots of people from the public who just wanted to come and learn about this amazing story, which I'm going to point out was on Quirks and Quarks this year, which is pretty awesome accomplishment for a scientist. But as Charles mentioned, the Department of Earth, Energy, and Environment is awesome. And I want to talk about a few things about why this is such a transformation, because it's not only transforming a department, but it is here to serve our community. In September, we launched the new department as an evolution of the Department of Geoscience. It is really a seismic shift. And we made it after extensive consultations with our faculty, students, industry, and community partners, and government. Together, we realized we needed to evolve. We need to meet the challenges of today and tomorrow, to think holistically about our Earth, our energy, and of course, our environment, especially things like water security. How do we maintain our biodiversity? And to train our scientists. It is no longer enough to train a scientist to be an amazing geoscientist or a chemist or a biologist. They need to think transdisciplinary. They need to learn now about economics, about policy, about business, about communication, because you need those skills to meet the challenges of tomorrow. And as a faculty of science, that is what we're here to do. We are here to serve the needs of Calgary, Alberta, and beyond. And we do that by training future scientists. And these are not your grandma scientists. These are going to be a new flavor of scientists. They will have a mix of both leading edge training in their disciplines, but they're also going to have those core competency skills that they're going to need to hit the ground running, the skills you need to be amazing when you start having that first job. So by launching the new Department of Earth, Energy, and Environment, we are broadening our focus to be truly transdisciplinary in how we approach science. We are attracting leading researchers in energy and environmental science, and we are here to secure that pipeline for Alberta's bedrock industries. We are getting science done for our city, our province, and our country. And I'm going to point out that this new department, Earth, Energy, Environment, is the first of its kind in Canada, and it really is the future of earth science. And this is just the beginning. We're in the process of launching a new energy science BSc program, which will truly be interdisciplinary. And it was designed 100% with stakeholders at the table to meet the energy industry of today and tomorrow in Alberta and Canada. We will not only integrate hardcore energy science like the chemistry of batteries, nuclear physics, solar, wind, geothermal, you name it. But we're also incorporating skills like economics, policy, business, because this is what the energy sector needs for today and tomorrow. So before we go further, we're going to take a couple minutes to play an amazing video about the launch of this new department, because it truly captures what we're in stage for.
From the highest mountains to the deepest oceans, the Earth is a place of wonder that supports life. The world, however, is changing. From evolving energy needs to the climate crisis, we are facing challenges. Addressing these will require diverse perspectives, creativity, innovation, and leading-edge science. Earth at UCalgary is driving change. We're building a community of inventors, dreamers, and doers assembled from diverse fields disciplines, and backgrounds. The foundation of our community is our students, and we are preparing them to be ahead of tomorrow. Together, our community will tackle Earth's problems. Together, we will get science done. We are Earth at U Calgary.
But that really epitomizes what this department's about. And you'll hear a lot more about this department as we go, and it's gonna be called Earth at U Calgary. So if you need to search it, search Earth at U Calgary. And you'll see it all around here, and the series is titled EARTHx. And just as our department has changed its flavor from geoscience to Earth, energy, and the environment, so has the Gallagher series. They were so generous in sponsoring this event and continuing to sponsor it with a larger and bigger mandate. We will be focusing on talks all across the gamut, anything to do with Earth, energy, and environment, and really focusing on things that matter. Big discoveries, fun discoveries, things that are going to change the world. And because we want to serve the community, and part of serving the community is bringing people together to learn about science. So I'm really happy you're here because the world really does need new science. So I hope you'll continue to join us for all our future EARTHx talks. They will be bigger and better as we go. They might be in different locations, they might have different flavors, but every single one is going to be as awesome as the one you're going to see tonight by Rachel. So with that, I'd like to invite Charles back to introduce our awesome speaker. Thanks.
Thanks, Kristen. It is indeed a pleasure to introduce this evening's speaker. Dr. Rachel Lauer is an associate professor in our department here at the University of Calgary. She joined the university in 2015 after completing her PhD in geoscience at Pennsylvania State University. Her research is focused on submarine hydrogeology. In other words, she studies the movements of fluids in the oceanic crust beneath the sea floor. This work has enabled her to create unique geophysical models and to travel to some places where very few humans have visited, like 4,500 meters below the ocean surface in the deepwater submersible Alvin. Dr. Lauer's work has important implications for understanding our natural world. For example, her hydrogeological modeling intersects closely with predictive factors for major earthquakes. In addition to her academic work, she has also worked as a geophysics consultant on both local and international projects. In June 2023, Dr. Lauer participated in an international expedition that quickly became U Calgary's most widely covered science story of the year. The expedition that you are about to hear has been featured on BBC, CBC's Quirks and Quarks, CNN, National Geographic, USA Today, NPR, and more. What's exciting about tonight's full-length presentation is that we're going to hear more detail and insight than any of those publications and news articles so far, and we will hear about one of the world's most intelligent and fascinating invertebrate animals, the octopus. Please join me in welcoming Dr. Rachel Lauer for her talk, Discovering the Deep, Ocean Exploration, and an Unexpected Find.
Good evening, and thank you both Kristen and Charles for that awesome introduction. It's an honor to be here tonight for this inaugural series. We're hoping to broaden the base of our audience and really think about the ways that discovery and transdisciplinarity, in this case, in my case, actually motivated and created the unexpected find that I'm going to talk to you about today. I also want to start by obviously thanking the Gallagher family for their philanthropic support for this talk series, the best talk series at the University of Calgary. And I'm going to talk today about what is actually over a decades-long series of individual discrete projects that evolved through that decade to ultimately what happened this past summer. Okay. All right, so roadmap for the talk. I hate it when people do this, but sometimes I get lost in talks. So first, just going to start about who is this person standing up in front of you? Why is she here? How did she get here? I'm going to talk a little bit about the importance of deep sea research. For many people, deep sea research is something we just don't think about unless we're reading a National Geographic. Act 1 is going to be talking a little bit more about my research in particular, focused on seamounts, and as Charles mentioned, hydrothermal circulation and hydrogeology of the seafloor itself. Don't worry, I'm not going to talk about any math or modeling tonight. Act 2 is going to talk about the revamped mission after the 2013 and 2014 cruises that led to a discovery that we could not explain based on the scientists that were present on that cruise. Hint, there were no biologists on that cruise. Then we're going to move to Act 3 and talk about the discovery this past summer, the team that was involved in that discovery, the tools that were required for that discovery to be made, and why it was so important. And then briefly, I'm just going to touch on what's next for this particular journey. Okay, so to start, just going to back up, and for those of you, some of you, I know I invited people who are not professors. Oh my God, you're at a university and you're not a professor. That's what we're hoping to do, is include more people in these talk series. And I just want to explain what it normally looks like to navigate that path to becoming a professor. In my case, it would be a love of physics, great in high school, undergrad in physics or geophysics, if you had a geophysics program, moving into a PhD in geophysics, assistant professor of geophysics. Fairly straightforward. That would probably describe maybe 75% of professors. This process of undergrad and PhD can encompass about 10 years of one's life, so huge commitment. And that was not my path to where I am right now. So briefly, just to describe this, I'm going to zip through this because there's a lot of squiggles, not a lot of straight lines in this. Started the same way, love of physics, yay. Okay, then that led to good in high school, got better, got to the point of maybe greatness in high school, lost confidence, had a bout of depression, eating disorder, eventually ended up with not a BA in physics, which is where I started, but a BA in psychology, which is not surprising given what I was dealing with. Much to the chagrin of my parents, I left that degree, did a brief bit of counseling, and then waited tables, did some drywalling. Bartending was really the pinnacle when I was making good cash as far as they were concerned. And then I was like, wait, I still love science. Okay, so I went back. In the US, college is university, took a bunch of classes in science, took a year of physics, chemistry, biology, kicked ass in it, got a job in geophysics, having never taken a single course in geology or geophysics. And they hired me and sadly called me a geophysicist, which was embarrassing, felt like a total poser. And that led me to get a master's in geoscience, including a lot of coursework in hydrogeology and geophysics. More squiggles. Called a geophysicist again, felt like less of a poser, awesome. And then I started a PhD in hydrogeology, terrestrial hydrogeology. Super pumped, feeling good about myself. Found out my advisor was a creationist and believed the Earth was 5,000 years old, so I left that. went to work in a bike shop, raced my mountain bike for a couple of years, went back to school for another program and got a PhD in marine hydrogeology and got hired here as an assistant professor. So what's the point? And I think it's important to highlight that the paths we take to get to these positions can be wildly different from one another. And I think we should value our non-traditional paths. I actually look for non-traditional students. I hate that term, but it's something I have started to embrace as a superpower. And the reason is we value diversity. Companies value diversity, diversity of thinking, diversity of experience. Having tackled adversity as a result of that diverse experience actually is and can be considered a superpower, and it is, for me, a superpower. So I wanted to start with this as sort of an introduction to transdisciplinary research, since I have now just talked about 3 different disciplines. Okay, so can't really do a talk for the public without an XKCD image. This is a little guy, day 44, still stranded on an island, nothing but flat, empty water as far as the eye can see. And this is actually how most people think about the deep ocean. Okay, as it turns out, what's happening below the surface of that ocean is an enormously diverse set of communities and ecosystems that are all connected to one another and to us. Obviously, I'm not sure what's going on over here with this squid and the whale fighting it out, but the other thing that's happening in our deep oceans is evidence of us. We are everywhere you look, despite the fact that our vast ocean is almost unknowable in its vastness. Every single cruise I've been on, I've seen evidence of humans at the seafloor. Whether it's dredging, whether it's Coke bottles, whether it's beer cans from the 1950s. We are there. Another way to look at the seafloor, this is a New York Times infographic that came out right after James Cameron went to the deepest part of our ocean. So when we talk about the deep ocean, what I mean by that is everything below 200 meters. Okay, so from 0 to 200 meters would be left out of what I'm talking about today. That leaves pretty much everything. And just putting this in scale, this is a cross-section that is across the Marianas Trench, of course. This is the deepest part of the ocean, which is why James Cameron had to go there. But it also just shows some of the depths and some of the highlights here. So estimated deepest diving military submarine up here, complete darkness below about 400 meters. The depth of the Titanic takes on a whole new meaning after this year's events. And then the average depth of the world's oceans is over 3,000 meters deep. Obviously, we have submersibles that can visit those depths. The US, China, Russia, France, Japan all have submersibles that can go to depths greater than 3,000 meters. And in fact, all of these vessels can now go up to 6,500 meters. So in a short time, we have gone from 4,500 meters as our maximum depth to 6,500, just showing how much progress can be made in a short time. Okay, so I'm going to do a glancing blow on the science. Don't worry, no equations, but I am just going to introduce the importance of ocean exploration in general and marine research like the stuff that we were doing this past summer. So why is this important? Well, there's an interesting graphic here showing all of the black parts of the ocean are places that we've never been with a ship. That means we've never used modern technology to even image the seafloor from the ship, okay? And that is basically everything, except for where you see ship tracks. And it turns out when 71% of your planet is the ocean, you're not going to actually just zigzag across it like you're mowing the lawn because it's expensive and time-consuming, and ship tracks are meant to optimize distances between 2 points. So we know the ocean makes up most of the Earth's surface, and we also know that more than 95% of all the habitable space on this planet is in our ocean. Conservatively, I would say 10% of the seafloor has been mapped, but I saw an article that said 20, so I'm putting 20 up here. So 20% of the seafloor on our planet has been mapped with modern multi-beam technology. And humans have physically laid eyes, either through remotely operated vehicles or actually going down in a submersible on less than 5% of our seafloor. So it's vast, it's remote, and we know almost nothing about it, and it's on our planet. The other reasons we should be thinking about this vast ocean is the services that it actually does for us as humans. It is constantly regulating climate at a scale that is higher than anything on this planet. It is taking up 90% of the additional heat that we have created as humans through extraction and burning of fossil fuels. And it has significance for feeding many communities, particularly coastal communities and particularly in the global south. So the fact that we have higher resolution maps of Venus, Mars, and the moon is a problem of access. It is a very difficult environment to work in because you're operating at pressures that are 300 times what we experience in our daily lives. Better maps will help us understand important processes that we see breaking down right now, like ocean currents. Understanding the bumps on the seafloor actually allow us to understand how that surface interacts with the ocean above, creating currents that transport things through our oceans. Marine habitats and biodiversity, which are going to be pretty much the focus of this talk, I would argue are incredibly important to us as humans, not just for the medical research and discoveries that they provide through biomimicry and actual cures for diseases, but also because of the wonder that they provide just by representing places that we have never seen before and adaptations that we have never seen before. And for those of you who care about deep time and old ancient Earth, Charles, shout out to you, a lot of the branches of life that have evolved over the 5 billion years or 4.5 billion years of our planet are represented within the deep ocean. Probably the best example of this are sponges. They went from 500 million to almost 1 billion years old in terms of how long they've been on this planet and in the record. And then, I don't know why I put a picture of an anglerfish up here, except they're really freaking cool. This one is a female anglerfish because she's got the fancy jewelry. All right, so this is going to get a little bit into my science. Again, I'm going to leave out all the equations and just try and keep it interesting. But seamounts actually perform an incredible function in our oceans that wasn't really known until about 25 years ago. So why are seamounts important? Well, it turns out as the crust is born at the rift and spreads, it becomes sedimented, so much so that that sediment prevents any ocean water from going into the crust or coming out of the crust. It forms this impermeable blanket that keeps the ocean and the water in the crust separate from one another. And these seamounts actually provide the only places where water can go in and come out somewhere else. So this process of what is called hydrothermal circulation, where water goes in one seamount and comes out another, has the capacity to change the entire physical state of the ocean crust, how it evolves as a function of that change in temperature. It is capable of washing away enormous magnitudes of the heat that the Earth is releasing as a function of cooling, which is done since it was created. This process also, because of the magnitude of this process, is capable of altering the chemistry of our oceans. And it also means that these places where water is coming out of the seafloor are providing incredible opportunities for biology. And that biology is not just the microbes that are living in the crust that we now know are making up this massive biosphere, but also the critters that are living on those seamounts where that warm water is coming out and providing them with habitats that may actually promote their life cycles. So this process of water moving in and out is called hydrothermal circulation. And this is just a little schematic showing exactly how that works. On the left, we have a recharge site, and that is where cold, dense bottom water is going to go into that little outcrop that's sticking up above the sediments, make its way into the crust or the aquifer, where it heats up as a result of being closer to that source of heat, and eventually make its way out one of these discharge sites. What happens as this side gets cold and this side gets warm is you get a pressure difference between them that drives what we call a hydrothermal siphon. So these can ultimately be self-sustaining systems that once they start are continuing this process until that change in temperature is insufficient for them to be connected. This process is actually accounting for 18 to 20% of the global heat loss in our Earth. And that is because most of our heat loss is happening in the oceans. Okay? Most of the hotspots are at the mid-ocean ridges. So of that heat loss globally, again, up to 20% of it is due to this process. The other important part here is that that process is recycling the entire crustal reservoir every 1,000 to 10,000 years, and it's recycling the entire ocean every 100,000 to 500,000 years. So these sound like big numbers, but to geologists, that's like a week. Okay, so very, very massive process. And the reason we know this is because we've actually studied how the Earth crust forms, how it cools, and we have enough heat flow measurements across the entire floor of the ocean to be able to understand the global implications of this process. So, Costa Rica. Why were we in Costa Rica? Well, it turns out 10 years before we went to Costa Rica, there were studies done that actually looked at this area of the seafloor that is shaded on this side and contains about 11 outcrops or seamounts. The distinction between a seamount and an outcrop, I should mention, is if it's a kilometer above the seafloor, it's a seamount. If it's anything less than that, 999, it's an outcrop. So I'm just going to refer to them as seamounts or outcrops without, hopefully nobody's here to ding me for that. But what's shown here on the right is a bunch of these dots and circles, and what they represent are how much heat is actually coming out of the seafloor in this particular location. And again, we know based on these calculations, if the Earth's crust is 110 million years or 20 million years, it should have a very specific amount of heat coming out. And all of these studies and surveys identified that within this area, 70 to 80% of the heat is missing. And there is no physical process that is capable of removing that much heat unless you have extremely high fluid flow rates. That means that the crust is permeable and it moves water from point A to point B very quickly and allows massive throughputs that can remove that much heat. Another look at these, there are two outcrops that are important in this system and I'm going to talk about. One is this tiny little nugget that's called Dorado. Dorado outcrop sticks up 90 meters above the seafloor. It is about 2 kilometers long, very insignificant, wouldn't even show up in most surveys, and happens to be the site of a giant discovery. This giant guy over here is called Tango Sed, and we know from heat flow that water is going in this guy, and 20 kilometers away, based on our calculations back in 2013, the only place all that water could be coming out was Dorado. So I wasn't part of the actual writing of the grant, but my postdoc advisor was, and got funded for 2 cruises. One to use Jason, which is a remotely operated vehicle, to go to Dorado outcrop and find that source of pristine water that's coming out, because microbiologists and chemists want to study that pristine water, because the only other places we can sample are places that have been contaminated by drilling. So if you care about the microbes and the chemistry, you need this pure water. So how do we do that? Well, this was back in 2013. We used a suite of tools. Jason is the remotely operated vehicle. Sentry is occasionally used in a tethering mode to Jason. And Jason and Sentry together can do incredibly high detailed mapping of the seafloor. They can measure temperature and chemistry in the water column itself and directly sample the water column. They can use sub-bottom profilers to measure sediment thickness. And Jason can do just about everything else. I don't know what I'm doing here. It looks like I'm arguing with Jason. I think that was the first time I met him, and it didn't really hit it off that first time. But this is Jason as it's being lowered into the water. And the good thing about Jason is, unlike an HOV or a human-occupied vehicle, there's no humans in it. So it can just work until it breaks, which is exactly what you do with Jason. So we were funded partially with Jason and partially with Alvin because everyone wants Jason, because you don't have to come up after 8 hours because humans aren't involved. Okay, so what did that work produce? Well, you can just see some of the bathymetric data that was collected. Here's the old map we had of Dorado outcrop. Look how it looks like a peanut at the seafloor. This is the new map that came from that mission. So our resolution was obviously 100 times better than the original mapping. And this is the kind of mapping that really needs to be done to actually understand what's happening at the seafloor. So how does this thing actually work? I mentioned it's tethered to the ship, and it's actually plumbed into a comms vessel on the ship that allows a pilot to operate it, who's usually a mechanical engineer with training, many years of training in operating it. It has 2 manipulators that are very strong, but also have incredible dexterity and allows it to grab tiny samples without smashing things like a Hulk, despite being very strong. In this case, it's actually sampling something from a black smoker, which is the, perhaps sexier cousin of the seamounts, because the black smokers are what everyone knows about. But they're really only responsible for activity like this really close to the ridges. And the rest of the ocean circulation and overturning, the workhorses in that are these outcrops. So another look at the ROV Jason. This one is from a researcher in Tasmania who took the picture. They're actually conducting a heat flow measurement. I'm not sure how they're doing it, but that's what they've stuck into the seafloor there. You can see this is a unique vehicle in that it's maintained neutral buoyancy when it needs to. Everything is plumbed in with oil. And the skid in front of it allows them to do all sorts of biological sampling, sediment sampling, and cores. For fluids, you actually have ways to trigger Niskin bottles within the structure of Jason itself to actually sample as well. Okay, so I said our goal was to sample pristine water from the ocean crust. Here's a video, I hope the video plays, of this happening. And that water is shimmering because it is 10 degrees higher than background and therefore has a different density. And that was the target. That was what we were looking for, is this shimmering water that we could sample, representing the pristine water that's just come from the crust. The device that was used there is also, it's a reverse engineered cow dewormer that we use to operate very simply at the seafloor by triggering it and pulling in a volume of water. Okay, and that's kind of a theme in this talk. It really pays to have low-tech things that cannot break when operating at the seafloor. Okay, so we got our first fluid, went back, this time with Alvin. This is a picture I took from the inside of the submarine. Went down to the same locations to now pick up some of the experiments that we left on the seafloor the previous year. Alvin gets launched from massive A-frame on the back of the ship. And this was a second generation of Alvin. This one had a whole 9-foot interior sphere instead of 8.5. So it was giant. But again, I mean, you're like crammed in there. It's not for the claustrophobic people in the room, definitely. You're touching the other 2 people in the submarine for the entire 9 hours. And in this case, 2 hours down, 2 hours up, 5 hours on the bottom. Okay, so awesome. I haven't gotten to the good stuff yet. So we got our pristine water. Who cares? The biologists cared, the microbiologists cared, and the geochemists obviously cared. But it turns out that what we discovered when we got there, and this pilot I just showed in the last screen has done over 500 dives. He was like, I have never seen this much life anywhere at the seafloor. I'm like, yeah, octopus, cool. Again, hydrogeologist, geochemist, and microbiologist. Like, we're not used to charismatic megafauna. So there's some of the little scenes. We got a little sea star. We got these ladies like in the brooding position. I later learned that's the brooding position. When they have their legs wrapped around themselves and they're ready to deploy them to attack, because these are like super moms, best moms on the planet. I'll tell you why later. And then we were also there to, again, pick up those experiments that we'd left on the seafloor. Okay, so cool. We published. This is a paper that was actually someone taking all of the video footage that we had assembled through all of those dives, looking for that freaking water that we finally found, not caring about the octopus, and published this paper that basically suggests that all of these octopus that we saw, these 90 to 100 octopus, the first octopus nursery ever discovered in the deep ocean, was basically an ill-fated, terrible mistake by these octopus. Like, they liked hanging out in the warm water, but that water is supplying less oxygen. So the prediction was that all those eggs we saw lining the cracks were not viable. And sure enough, if you zoom in, and we're going to show it briefly in the next slide, if you look at the octopus eggs, they're hanging in these cracks where that warm water is coming out. They've carefully cemented them into perfect little rows. If you zoom in, you can't see any of the little eyes that you should see to signify a viable embryo. Again, we did not know that because we were biologists, microbiologists, chemists, and geophysicists. Okay, so that's a sad story. This is the video that was published at the end of that paper and led to what I'm going to talk about next. So all these eggs, no cute little blue eyes shining out of them. And the prediction was all over the news. It was like the saddest story of the year, in my opinion. Probably no one didn't make it up here, but colony of beautiful doomed purple octopus found off Costa Rica. Oh gosh. Smithsonian, science, everyone's picking up this awful story about these poor octopus. And if you read down here, and nobody can see this, so I'm going to pop it up on the screen, what it says is that 16 out of these 17 deep sea octopuses are brooding young, but they're all fated to die. Okay, so most science is not motivated by a sad story, but the group that was on the ship with me, the microbiologist, became a champion for figuring out if this was true or not. And that woman, Beth Orcutt, is amazing, and she was responsible for assembling the right team this time to go back there and actually test that hypothesis that had been all over the news, these sad stories. Okay, so fortunately, I didn't know Schmidt Ocean Institute existed. I'd sort of gone through traditional channels and the US Navy and all of the fleet that is generally associated with scientific research. Turns out that Schmidt Ocean Institute, who was started by Eric and Wendy Schmidt, you may know Eric Schmidt, former CEO of Google, so lots of money. And Eric, and in particular Wendy Schmidt, is in love with our ocean. And what they have done through philanthropy is make this incredible research vessel, I'm going to show you, available at no cost to scientists who competitively write grants to access the vessel. And this is not like any vessel I've ever been on. This is like, it's like being on the space station compared to being in a dinghy. Not to, throw too much shade on the previous ships I've been on, but this one was ridiculous. Okay, so they're a nonprofit, and they also honor and promote themselves as being very transdisciplinary. So they don't want to see a bunch of people like me on the ship. I want to do heat flow all day. Like, that's not fun. We want to see a team of people who are all coming together across disciplines to actually solve a big problem. And they also value diversity. And in the cruises I've been on, the 7 cruises prior to this one, I have never seen significant representation from the home country. And that's Costa Rica. We had 1 Costa Rican on 1 of the cruises out of the 3 that I've been on. Okay, so here's a glance of the new ship. They're not very creative with their naming. The first one was Falkor. This one's Falkor 2, T-O-O, haha. And this ship is, currently, I think, the most advanced scientific vessel that exists on the planet. It was previously used for installing cable and wind turbines in the ocean. And as a result, it has some of the incredible things that I value. And that is, this is the best dynamic positioning system of any scientific vessel. That just means it can hold position really, really well. And that's really important when you're trying to launch an ROV over the side of the ship that has its own positioning system. And the ship itself is moving as well and rocking back and forth. And this is a really hard problem to solve. Okay, so they've nailed it with this ship. They also have the most sophisticated high-performance computing system. They have 3 different types of multi-beam bathymetry for different depths. They have wet labs. They have dry labs. The food is amazing. I'm not going to show you pictures of the ship because I don't want everyone applying for ship time. But it is capable of just about anything you can dream up. Here's a beautiful shot of it top down. And what's insane is this is the size of a football field in the back here. It's just a massive ship. And it has apparently, I think I verified today with Googling, thanks Eric Schmidt, that they have the largest crane of any vessel. Okay, so pretty much anything you want to lift up and move around, they can do on this ship. And any kind of science you can dream up can also be done. So the workhorse in this is actually Sebastian. Okay, so Sebastian is very similar in every way to Jason. Okay, so it has a male name, but it also has, all of the bells and whistles, the junction box, the capacity to mount equipment onto its side and plumb it in so that you are basically operating on the ship all the way through 3,000 meters water depth to control something at the seafloor, which is really freaking cool. It's like the most expensive video game in the world. Okay, so Sebastian also has the same capability of being down there for a long time. Okay, so this is the new team. Okay, so this looks very different in many ways from the past teams I've worked with. And in particular, over 50% of this team is from Costa Rica, and over 50% of this team is women. And both of those things are very unusual. Okay, so the 2 co-chiefs, Beth, who I mentioned, she is a microbiologist. Jorge is a biologist, deep sea biologist and policy expert, coral expert, cephalopod and physical oceanographer, geochemist, corals, gut biotic specialist. I don't know who that is. Julie, also microbiologist, policy expert, microbiologist, biologist. My PhD student, also a geophysicist, geochemist, ocean plastics researcher, geologist. Miguel is also a geochemist, octopus expert, who's the one that speculated they were all going to be dead when we went back. And we also had 2 artists on the ship. Okay, so we had 1 artist from Costa Rica, from the home country, as well as 1 from Maine. And then Alex, who is referenced at the end, is responsible for all of the good pictures that are included in this talk. We actually had, as part of all of Schmidt's cruises, they call them cruises, I know that sounds weird, but it's a cruise. You'll get your own videographer, and this guy's made award-winning documentaries, and he just followed us around and made amazing videos. Made us look like rock stars, basically. And this is a picture of us on the deck, and right over here off the screen is the little van where Sebastian sits when he's not working. And this is the whole team, and you might notice that each of the people should be holding a tiny little knit octopus that were made by my niece I actually gave her biggest order ever. I had her make 19 octopus, tiny ones, and I gave them out to everyone at the beginning. And I've got 2 up here if you want to come look at them. Okay, so we're going back, and in particular, where are we going? We're going back to Costa Rica, and Costa Rica is obviously in Central America. We are just, and up here is Nicaragua, down here is Panama. The Nicoya Peninsula sits inland of a subduction zone. So you've got a plate going under another plate, and in this area, there are all of these outcrops that we know were responsible for removing 70 to 80% of the Earth's heat. Okay, so lots of action happening in these things, but we had only been to Dorado. So we've been to 1 outcrop twice, once with our own eyes from the sub and as well from the ROV. And the mission was, well, first of all, let's go back to Dorado and figure out if they're gone, which sounds awful, or if there are there, we came back with permits to actually sample. Not my favorite part of this trip, but to sample those and determine if they were a new species, because octopus had never been seen in large numbers before, especially in the deep ocean, and they shouldn't be thriving under these conditions. And then the second question was, what else is there? We have no idea what else is potentially happening at all of these other outcrops. And I personally wanted to take heat flow measurements to understand if we can actually find what would be the 3rd pair of outcrops that are hydraulically communicating with each other in the world, which seems, think about that. We have, of the probably 1 million or more than 1 million outcrops at the seafloor, we know 3 places where water is going in and coming out. There's a lot to learn. Okay, so again, the plans were explore that relationship between the water going in and out of the crust and these octopus. Is it helping them to thrive? It is actually part of or responsible for them no longer being there. And then also just mapping the biodiversity that we see. We had so many biologists on this ship because part of what we were doing on our 24-hour operations is cataloging every living thing that we saw from the live stream as part of a census, a global census of our seafloor. So we targeted 6 particular locations, and 5 of them we'd never been to before. So these were 5 outcrop / seamounts. All right, so this is a drone picture, obviously not by me. This is actually, if you zoom in right here, you can see us having a barbecue, which is another thing we've never had on a ship. An outdoor barbecue right before we set sail. So we're still in the port in Punta Arenas in Costa Rica. And before we actually talk about what we saw, how awesome it was, I'll show you a video of me freaking out and embarrassing myself. I want to just share with you what it's like to be on a ship doing this kind of research, and also just how incredible an opportunity it was to see it function as well as it did on this particular ship with this particular team of people. I want to start by saying the idea of workflow on a ship is a hilarious concept because every day something comes up and all bets are off. Everything you had planned for that day is off the table and now you're doing something completely different. So it is not for people who like straight lines. And obviously I've shown you I do not like straight lines. So there's a little bit of chaos every day, constantly reevaluating what we thought we were going to accomplish and what we will accomplish. So keep that in mind as we sort of work through this. Okay, so every day, we did have a COVID emergency and had to medevac somebody off, so it's not every day. But most days at 5 a.m., Sebastian gets plopped into the water, and we start our live shifts. Every second that thing is in the water at the seafloor, which again takes 2 hours to get down. So at 7 a.m., your shift starts. Somebody is talking online about everything that we're seeing and entertaining questions from the public, whether they're coming in through the YouTube live feed or Twitter or other sources, or just answering questions that are coming in between people in the room. So what does that look like? Well, here's the control room. This was probably the second day. They had to finally kick us out because we had like 19 of the 19 scientists packed into the control room all the time, like, wee, and it's live feed. So everybody's like, you guys shut up. We're trying to do a live feed here. But there's 3 positions, and everybody takes a rotation through each position every day. So not everyone who's the team lead. So I was the team lead for heat flow. So I got to be in the hot seat. This is Diva Amon in the hot seat. And basically you are telling the pilot, who is over here with the baseball hat on, he's the one playing the really fancy video game, and controlling the manipulator arms, controlling the position, controlling the sampling. And you're also in control of the camera, which was really cool. So this is the first time I've been on a ship where you're actually controlling everything that the public is seeing as well. Because again, this is all live streamed. So you're the commentator, then the person sitting here, or these 2 in this case, have 2 computers that are both open to capture every single thing that we see. So you're like snapping photos, writing down the names. In my case, it's like red thing, because I'm like not a biologist. But fortunately, on my shift, when I was in that seat, I was seated next to a biologist who would help me understand what I was looking at. And then right here, actually, you can get a glimpse of all of the buttons we had set up to immediately capture whatever was in the field of view so that we could do this seafloor census along these transects. Okay, here's another view of that control room from the back of it. So it's not a huge room. There are about 30 screens that are all capturing high-resolution video. The amount of recorded footage that gets captured in one of these cruises is insane because 3/4 of their cameras are 4K. Okay, so you need like a suitcase full of hard drives if you want to take all the footage off the ship. Here's a lovely image of a PhD student in my group chatting with Gustavo about what they're seeing. And at this point, actually Rob is sitting in the position where we would operate the heat flow probe, which was mounted on the side of Sebastian. And opportunistically, we would take measurements to try and identify places where it was cold, water was going in, or another location where it's warm and water is coming out. Okay, and you can also see, as much as I try and stay away from social media, I was on it the whole time I was on the ship because, how often do you get to see oh yeah, today I saw a tripod fish. They're right out of Salvador Dali. I've never seen anything like them. And that was probably 3 or 4 times a shift. There was something that I thought could not possibly be real at the seafloor. The other part of this, after we're done with our shifts, which are unofficial because they're scattered throughout the day, is every day at some point, either Jorge or Beth would come up to me and say, Rachel, Rob, we need to do something totally different tomorrow. Can you pick locations and create a dive map? And overnight, we want to multi-beam this seamount. Can you come up with a track line based on ship speed and transit speed? And so basically, I do math and figure out and plot ways that we can optimize every second of the ship time that we have to be able to either be mapping the seafloor while people are sleeping and pilots are sleeping who navigate the sub, but also figuring out the next day or figuring out something that just happened that requires us to totally pivot. So some of that mapping work, this is an example of something that Beth would say, Rachel, I need a map drawn up of, you have 6 hours, how much multi-beam can you do? Well, multi-beam is a swath, so you have to have some overlap, and the ship goes a certain speed, so you do some math and plot those lines. And then you end up with an image like this, where you have very high resolution that shows this side of this seamount has actually slumped, and it looks like ended up over here. So when we were actually plotting our track lines for the next day, we avoided that part of the system because it's less likely to be interesting and habitable to octopus. Every day at 7 p.m. after dinner and before the sub comes back onto the deck, every single day we had a science meeting. I have never had that happen, and that is thanks to Beth Orcutt, who made every single day the most inclusive and representative of every single objective. You know, one person wants water column data, one person wants Jabatella octopus, one person wants fluid samples, one person wants geochemistry from the sediment cores. I just wanted heat flow data. And she somehow managed to, every day, over an hour meeting, ensure that everyone's needs were at least acknowledged, if not met. And every day, everything changed in this meeting. And that is what a really good leader does on a scientific cruise like this. I've literally never seen it happen before, and maybe never will again. Well, maybe I will again, hopefully. And then on 8 p.m., after 8, well, it depends on the depth, but usually 8:30, Sebastian's back on deck, and that is Michael. Michael is an artist, and Michael is helping to unload. In this case, it looks like a coral sample, and there's this line of people carrying samples, processing samples. I think the next is showing, oh yeah, here's Gustavo. He has the actual sediment cores that were done, push cores that were done from the ROV. And then over here, oh wait, there's Mila, who is a policy expert and the chief scientist helping to get muddy and process all of those samples. So it's literally all hands on deck. I was on 3 teams. I was on water, sediment, and heat flow. So depending on what's happening, everyone had membership in different teams to ensure that we had coverage and things happened quickly so people could get sleep and get ready for the next dive. The other part of this, which I mentioned, we had to sample these octopus to know if there's a new species. And so this involved, every single egg that was collected was photographed and cataloged. And this process is probably one of the things that took the longest. And then refrigerated, and then processed for storage, and then permitted. And I've never worked with biologists before, but the amount of processing that happens on their end required everyone to pitch in and really ensure that this work happened, again, in a timely fashion so that people could sleep. Okay, so I'm not going to show you what multi-beam looks like, but the result of that is something like this. Okay, so this is Dorado outcrop, looking way different than the peanut that he originally looked like. And this is the track line that was created to plan this actual dive. So we were going to come out over here, land close to the abyssal plain, start our journey up to the side of the outcrop, and these 3 flags were the places that we wanted to visit. And they were places we wanted to visit because they were places we had been before in 2013 and 14. And in that time, we had left a bunch of experiments because we were hoping that we would come back at some point.
Costa Rica is about 90% deep sea, and most of it has never been explored. So this expedition has been really critical on local levels, on regional levels, and on global levels. Costa Rica is actually going to be hosting in 2025 the United Nations Ocean Conference. With Costa Rica in that leadership role, this cruise provides a brilliant opportunity to really allow us to take the science to decision makers at that forum and really put the deep sea center stage.
Para la mayoría de la gente, el mar es eso, es una superficie de agua y no se imagina lo que hay. El fondo está a 3 kilómetros de profundidad y lo que estamos viendo allá en el fondo es todo otro mundo allá abajo.
We have confirmed a number of our hypotheses and major objectives on this expedition. So we've confirmed that there are octopus nurseries here.
The eggs were viable, which has just been mind-blowing.
There's a baby! A baby! We've found things we weren't expecting, like a skate nursery. We discovered a new low-temperature hydrothermal vent. It also has octopus brooding their eggs there.
I was so excited. Beth was like, Rachel, go outside and scream. I was bouncing off the walls.
Bingo. Great moment for us.
We've gotten so much more than we thought we would in terms of additional information about this field of outcrops that we're studying. It's just been mind-blowing.
The octopus, having undergone a population boom, it's the only way I can express it, just tells us that life is incredibly resilient.
And for us, this cruise has been just an incredible success from day one. We verified a few of our hypotheses and then a few more within days after that, which I can't say how rare that is in deep sea exploration.
Pero había otra finalidad para mostrar al resto de los costarricenses y al mundo, mostrarles la maravilla que es el fondo del océano, de la columna de agua. Y la vida que tenemos ahí y la importancia de que esta vida se mantenga y cuidar este mar. Este mar es fundamental para mantener la vida del planeta. Tenemos una riqueza impresionante y que tenemos que cuidarla.
So one of the things we did on this expedition was map new seamounts that had never been explored before. And some of them we've been able to start exploring, but we still have other targets in this region. So we need to come back and see, do we find more nurseries? So we put out some instrumentation that's gonna measure the temperature, it'll measure the chemistry of these systems so that when we come back in December and recover them, we can start to get that data.
You know, this cruise has been one of the closest I've ever been on by a long way to equitable collaboration, and that's something that we really do want to see much more of in the deep sea community.
This is the kind of science I want to be doing, and it's going to lead to research for years to come.
Muchas gracias.
What was shown there was a lot, condensed into 3 minutes. But when we arrived at the outcrop, there were not 100 octopus, there were 200 or more in the same location. And what you saw were those little hatching babies. So not only are they obviously viable, but we're having a bit of a population explosion. Subsequent research has shown that these hydrothermal systems are actually acting as incubators and speeding up this process of egg maturity, which goes entirely against, again, the early hypotheses. Another thing that happened that I should mention is the discovery of the octopus nursery. The other one was a complete crapshoot. We were intending to head to the north, and this is ocean research in general. The fact that on this expedition, 90% of the things worked as they should is a complete anomaly in my experience. Usually when something disastrous happens and you lose like a $1 million instrument, it's like, okay, go to bed. What are you gonna do? It's at the seafloor. In this case, we were heading to the north and had done all of our ship planning and tracking and bathymetry mapping planned for an overnight. And we got a message from one of the local Coast Guard indicating that longline fishermen had set up 2-kilometer long lines that prevented us from going to where we were supposed to go. And that was one of those occasions when Beth came back and said, Rachel, Rob, we need a new plan. And so we planned to go further south and look at 2 outcrops we'd never been to before. And it turns out that the first one we went to was cold. Like, cool, maybe this is a recharge site where water's going in. There's one 2 kilometers away. Let's go to that one. Next day I went to that one. It was like Dorado. It wasn't as warm as Dorado, but we could see shimmering water. Definitely worthy of a second dive because apparently those longline fishermen were still prohibiting us to go to the north. And what we did was spent a second dive there, and that's when we found what is now at the time, the 3rd octopus nursery in the world with the exact same species, new species of octopus. And also the day after that, we found what we are calling a skate park. It's a skate nursery. So these big sea skates and hundreds of eggs all over another seamount that had never been explored. So this was just one of those trips and research expeditions where not only did everything go right, but the right team was there to handle everything that did happen. So what's next? Sadly, I will be here in December. This expedition is leaving next week. We just had our last meeting on Tuesday, and yes, I cried because I'm not going to be there. I was supposed to be on 3 cruises before this one this year. One of them got rescheduled. But in my place, my postdoc advisor is going to have to fill my shoes. So he's going on this cruise, and they're going back to collect all of the experiments that we left out, all the data loggers that have those time series that will allow us to understand whether or not the flow of these systems is steady state or changes as a function of tides or time of year. And also ideally come back and do some more biological sampling as well. And I think with that, I should probably wrap it up. And am I supposed to go to the, yeah? Okay, so I just wanted to get to my acknowledgements because I think there's another slide that I have to get to allow people to call in from home if they have questions. I just want to make sure that I mention, obviously, Schmidt Ocean Institute, without which none of this would have been possible, without their amazing ship, amazing team. COBRA is an accelerator, research accelerator that was started by Beth Orcutt for early career researchers who are just getting into deep ocean exploration, whether it's biology, geochemistry, geophysics, and provides them with a full 6 months of programming, all the way from how do you interact with people on the ship to how do you write a successful proposal. And she funded my travel and all of my needs for this trip. She got a lot of her money, obviously, from NSF, and I don't want to forget to mention Alex Ingle, who took all of the beautiful photos that I shared from the ship. And I think with that, I'm going to see if there's any questions. I don't know. Oh yeah, I'll leave this here. But I have to put up the other slide, right? With the, okay. Okay, just quickly, because these are so cool. So on the left is a tripod fish, in the center is an isopod, and on the right is a Dumbo octopus. On that one on the left, 3 million views on Instagram. Anyway, which is, you know, who knew that 3 million people could watch anything? But the guy in the middle was set to music, and it was hilarious, but I didn't have this set up to share properly. And the guy on the right is just one of the most beautiful creatures I saw at the seafloor, maybe besides the tripod fish. That's this, well, no, it's not the same species. This is this doesn't really look like a Dumbo octopus, but the little ears, what appear to be ears and are actually fins, are sort of the defining characteristic of the Dumbo octopus. And, well, I'll share this too. This is set to music. Wendy Schmidt really likes all of the posts on Instagram to have music, and she chooses the music. But look at the judgy, like super judgy. So I think the other term for them is glass squid, and they actually, with chemistry, create neutral buoyancy by controlling the actual fluid inside their guts. Crazy. Yeah, I did not choose this music. Just I think it's, oh, and it's a squid. So that was, again, biologists, please don't judge me. That was ink. That is about this big. We don't, when we're at the seafloor, we use lasers as like a scale bar because the lasers are 10 centimeters apart. This is in the water column on the way back, so we didn't have the lasers active, but yeah. And what else? Oh, I'm just gonna, am I gonna get pulled off the stage? Okay. You know, the other thing that I did and I didn't have time to talk about was almost daily outreach. And there were, I think, 6,000 people reached through our ship-to-shore communications that were in 3 different languages and 6 different countries. That's the other cool thing about being on a Schmidt vessel. They have 2 dedicated satellites, so we actually had Wi-Fi, which has also never happened to me. And that's mainly to support all of these ship-to-shore communications that they not only encourage, but they want to see your schedule, who your target audience is, exactly what you're going to be sharing and talking about while you're preparing your proposal. And I think I'll finally get to, there you go. All right. You want to come up here?
Sure. Thank you, Rachel. Thank you for opening our eyes to seeing how, a part of the world that most of us never get a chance to see, except maybe in the fossil record.
Yeah, you get to see it, yes.
But also opening our eyes to how important really great science is transdisciplinary. So, and your path, your career path, it was very interesting. I mean, after you finished the linear path, I went, well, that was mine. So, and then you had a very different one. So that was very interesting. And one of the things I think is the most important thing about science, the most important aspect is that you never know what you're going to discover next. So thank you for showing us some really cool discoveries. All right, we would like to open up the floor for questions. Do we have any online ones?
Nothing in from online just
Nothing.
yet. We've got a few on the floor.
Microphones here, so can we please ask your question so everybody can hear?
So I'm not a scientist at all, so you have to explain this in English. But the concept of seamounts, how do they get formed? What are it's something I know nothing of.
Yeah. So that's actually, I can answer that what we think, but most of what are seamounts or little bumps, these little extinct volcanoes, are formed close to the mid-ocean ridge. Okay, so you have upwelling of magma, and then it spreads and moves apart and eventually gets sedimented. But at the ridge is where most of that faulting and magma coming out that forms these little bumps that eventually get covered in sediment. And then as the crust gets older, they become the only places where you have active circulation of the ocean into the crust itself. Yeah. And there are other ways, like Hawaii, which is over a hot spot. And in that case, it's again upwelling of magma, but it's in a location that is stationary relative to the motion of the plate. Okay, so some of the island chains that are formed globally are formed by that process, and that happens away from the ridge itself. Yes.
Hi, I have two questions for you. One is from a biology perspective. You said that you took samples of animals from that depth and brought them up.
Yep.
I'm very curious. Doesn't the pressure differential basically make them blow up? And then my second question is, can we watch the live streams that are coming up in December?
Oh, hell yeah. Yeah, you should. I will be watching them. Yeah, so actually it turns out that everything that thrives at that depth is liquid and gelatinous. So really what happens when it comes up is it doesn't feel good because a lot of creatures are actually meant to be at that depth. You and I would not do well because we have lungs and we have gases in our body. Anything that's residing at that depth is primarily, it's a liquid. So its actual response to that pressure it's not going to do well in relieving that pressure on the way up. And I think 90% of the samples, I shouldn't call them samples, 90% of the animals, I have to do that because it was not my favorite part. Think about them as samples rather than octopus or cephalopods of some kind. So I don't think any survived the trip to the surface, no. And that was, this is the first, we actually had 3 separate meetings before we actually went to Costa Rica and got on the ship about how to deal with that part of our work because, I take heat flow measurements. I'm pretty utilitarian about my work. I don't get attached to a heat flow measurement as much as I do, a Jabatella octopus or some of these like moose octopus that are actually, capable of generating some emotions. So yes, but we actually, the permitting process for taking those samples and having them processed in Costa Rica was one of the most laborious parts of the preparation for this, because to verify a new species of octopus, you don't just need one octopus either, and to do any significant research, you need a sampling. Yeah, so that was not my favorite part, honestly. Was that a second question? You asked them both? How do you watch the live stream? Oh, how? Okay, so it's on YouTube, it's on Facebook, and if you go to Schmidt Ocean Institute and go to this year's cruises, there's a live stream for, I think they just wrapped up the Galapagos events, but it's 24/7. As long as they're operating at the seafloor, they have a live stream going. And you can ask questions and, yeah, I mean, and honestly, like the condensed version, the 3 minutes I showed are far more exciting than, some of it's like, another pile of sand at the seafloor. But like really the actual footage condensed is also available on Schmidt's Ocean website in these sort of curated videos that really put the story together in a way that is just really incredible.
Yeah, we've got some great questions coming in from online. Here's the first one. Question is, it was really interesting that artists were included with the research team. Could you explain a little bit more about the role they played within the team and the overall research there?
Yeah, so both the artists were making an effort to capture the wonder of what we were seeing at the seafloor. Michael is an artist in Maine, and they work at Bates College. And they have been doing deep ocean-inspired art for the past 4 years because of Beth. And Beth is also in Maine, so they have started a collaboration together. Beth and Michael have worked together through a bunch of shows and gallery openings, and they wanted to have a second artist to represent, obviously, Costa Rica. And Carlos Hillier, who represented Costa Rica on this cruise, is a performance artist, so he was just like cranking out stuff like 5 paintings a day. I don't think the guy slept. You saw a little bit of him painting on the ship. But both of them were also an integral part of Team Sediment and Team Coral, I believe, is their 2 teams. So they were actively processing every bit of the samples that were coming up. If there was help needed in another area, they were there as well. And I'm actually going to Bates in Maine to give a similar talk there. I was invited by Michael, who is working with a music composer and a choreographer, and they have recorded weeks of ship sounds that they are integrating into this soundscape. And I'd like their work to come here in a similar format to be presented to you all. So there was a lot of overlap between, which sounds crazy, I know to some people who haven't thought about the integration of art and science, but I think capturing the imagination of the public is how we bring awareness about not just the work we're doing, but the lack of knowledge and the lack of, and the need for further discovery.
Yeah. We got one more from online and then from the audience again.
Yeah, absolutely. So one of our sharp-eyed viewers online noticed that some of the photographs have NASA credits on them and wanted to know, what are the implications of this research for space research?
Yes! I'm so glad someone asked that. Okay, so it turns out that ocean worlds like Enceladus and some of the crazy places that people are studying right now and trying to understand, the deep ocean is an analog for those icy planets in some cases. Obviously different fluids, you have liquid methane instead of seawater or whatever, different boundary conditions, but my previous advisor, my postdoc advisor, Andy Fisher, is actually 75% of his funding now comes from NASA to create the same types of models that I've developed to understand hydrothermal processes at the seafloor. We now know hydrothermal processes are happening on these ocean worlds as well. So this deep ocean is a perfect closer analog that we can directly observe, given obscene amounts of funding and the right tools. Yeah. So that's a great question. Also the origins of life and how we got here. Most people are looking at the oceans and places like that where you have these extreme environments to sort of understand.
Any from the audience?
I'm wondering about the heat that's coming out of the vents.
Yep.
Is that a significant contribution to ocean warming, or is it insignificant?
That's a good question. The amount of heat, when you think about like black smokers are like hundreds of degrees, okay? Water that should be boiling, but it's at very high pressure. The types of systems that I study are very high throughput, so there's a lot of water going through, but given the size of our ocean, it is having zero impact. And the Earth the heat is the result of the Earth cooling, right? So the Earth has been releasing heat as a response to its age through time. And that heat that I was talking about being mined through this process is overturning our oceans, impacting the ocean's chemistry, but not making any changes in terms of adding warmth. In fact, our oceans are responsible for taking up 90% of the heat that we have, as humans, have produced since the industrial age. That 10% that our ocean is not taking care of is what we're dealing with currently. Yeah.
So we've got about 5 more minutes. I have one more from the audience, and then we'll go back online.
You've talked a little bit about how everyone was involved in sample processing at the end of the day, even if it wasn't your area of expertise. Do you want to talk a little bit more about if you had to undergo extra training for that, or if it was already in your scientific toolbox? And what did that look like? How long did it take?
Yeah, that's a great question. So I should have, if I had 3 hours, I could have talked about the process that led up to this cruise, which was, I think we had 16 hours of Zoom calls over the 3 months before we left. And that was literally breakout rooms where it's like, okay, this is how I want, this is the procedure I use. These are the chemicals that I'm using in this order. And we sort of subdivided based on interest and expertise, but also like, hey, that's cool, I want to learn that. And again, this is not a normal, usually you're in your silo, and that was not how this cruise worked for many reasons. But it gave everyone the opportunity to work with to learn something new. We did get the training. The training happened partially in Zoom prior to getting on the ship, but then once we were on the ship, we divided and conquered. Team sediment, go over here and figure out the procedures for extracting fluids using suction and rhizomes, and then the steps to follow for the subsampling of that. And same thing for people sampling from the water column. They had their own procedures and methods. All of that was shared prior to the cruise with the entire team. And then once we got there and saw how it all looked, it was like, yeah, I kind of want to be on Team Sediment. And you could we also rotated as well. So I got to be on all of the teams, except the biology, because they weren't going to let me near that. But and those are people actually dissecting creatures. And those are clearly that's not my wheelhouse. But yeah, the overlap was, for me, unprecedented, but also just really special because it felt like it was an integrated team. The other part of that is we had 2 policy experts on the ship, and for example, I did not know that over 90% of Costa Rica is deep ocean. The fact that a lot of these island nations, most of their real estate is offshore. And it really speaks to the importance of them being able to not just be represented on the cruise, but also be stewards for that moving forward and ensure that it's here for the next generation to appreciate. So yeah, we could wiggle around a little bit, which was really nice.
All right, so looks like this is our last question of the night. We've gotten so many good ones online here, so here's what we'll do. We'll make sure that we text everyone back, even if this is the last question that we can answer here, and that is to ask. Here's an audience member who's onto the transdisciplinarity thing, which is fantastic. Was there anything on the trip where all of the different disciplines, including the artists, had to work together to solve or overcome?
Oh my God, that's like an interview question. It's like, please name a time where you struggled with another person. Yeah, I mean, I think actually, the question that came up earlier about, you know, the sampling, the biological sampling for myself was hard. Prior to getting on the ship, I was very cavalier and was like, I'm a scientist, I'll be fine. But then I started seeing these octopus and another one, and I was like, I'm going in the other room. That was, I think, something that everyone dealt with, even the people who were there to sample the octopus. And about 2 weeks in, when we were near our quota, because we had to file a permit with not just, you know, the Costa Rican government, but also the permits to be able to import all of these samples, we actually had the artist, one of the artists brought us together to have a conversation about this, because they noticed that it was bothering people, and that, you know, as someone who does like geophysics and modeling, I've never seen a live squishy thing on the, you know, coming up and having to be processed, and it was really difficult. And I also think, you know, it's a testament to Beth, because we had literally multiple meetings about this beforehand in anticipation of just this thing happening. And Michael was the one to bring it to Beth's attention and require us to have an extra meeting to have a conversation about it, which I thought was incredible. Like you know, we were all very much in touch with one another and what was going on with each other. That's the other thing that happens on a ship. You can't get away from people. Like, you're there together for, you know, the longest I've been out is 2 months, and that was too long. But yeah, that was a really interesting and, again, first-time experience for me. I've been on cruises. I was on a ship for 2 months where we had one science meeting in 2 months. So just as another N member, yeah.
Okay, I think we have gone over our time, so we're going to
Sorry.
have to take a break there. Okay, you took my lead, but let's thank Rachel one last time for telling us her story, and it's a very fascinating story indeed.
Thank you.